Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Well, today I will start solving a Regents exam for Algebra 2, and this one comes from Thursday, January 22nd of this year, 2026. It's a 3-hour test. It's open like with graphing calculator and a straight edge. You are allowed these. And there are 4 parts, as you know. The first part is the multiple choice, and it consists of 24 problems. Each one is worth 2 credits. So I hope to finish it today, and then part 1, and then we'll see parts 2, 3, and 4 if we can finish them in 1 or 2 sessions. So we'll find out about that. Okay, so we want to start working and work intelligently, meaning you don't. Let's look, for example, at any problem. Let's look at the first problem. The first problem said the value of t in the equation 27 to the power of 6 minus t equals 9 to the power of t minus 1. The first thing you should see is that 9 and 27 are all powers of 3. If not, the problem probably would take forever. I mean, you may use log and try to find a way, and it's not that easy. So, excuse me. We know that 27 is 3 cubed. In fact, you should learn all cubes from 1 to 10, probably. They're so easy. But and we know that 3 is 9 squared. You also know that if you have any base, the same base, in this case, it would be 3, raised to the power of a, where a is any number, and then we raise that to another power b, that becomes x to the a times b, right? So that simplified things. So instead of saying 3 cubed raised to the power, no, I can say 3 cubed raised to the power of 6 minus t is 3 raised to the power of 3 times 6 minus t. So I can say 3, and then I multiply 6 minus t by 3 again, because 27 is 3 to the third power cubed. So I get 18 minus 3t equals. Likewise, 9 is 3 squared, meaning 3 to the second power, and it's raised to another power t minus 1. So 2 times t minus 1 is 2t minus 2. You don't need to take the log to the base 3 of both sides, because you are not showing answers. It's very simple. You just cross out the 3's and you say if they are equal and they have the same base, so the powers must be equal. How can they otherwise be equal? So I get 18 minus 3t equals 2t minus 2. I can move the negative 3 to the other side because it's positive. It's easier to do that. And then if I have the t's here, I don't need the constants. So 3t plus 2t is 5t. 18 plus 2 is 20. Dividing by 5, we get t equals 4. Which is number 4. That shouldn't take you long. The next problem, x minus 4 squared minus 5 times x minus 4 plus 6, and you want to simplify this equation. Don't, and I repeat, don't expand x minus 4 squared and distribute the 5. That would be terrible. Instead of using the x, instead of factoring x, factor x minus 4. If it's complicated, if you don't see it, say let y be equal to x minus 4. So x minus 4 squared becomes y squared. Minus 5, x minus 4 becomes y plus 6. And now we become a very reasonable quadratic equation. You want two numbers to multiply, that the product is 6 and then sum is negative 5. So it's y minus 2, y minus 3. But y is x minus 4. So x minus 4 minus 2, x minus 4 minus 3. You didn't need to do any of that. I could have said x minus 4 minus 2 and x minus 4 minus 3 from the get-go, and that is 4 again. Okay, now let's move to the second page. Question number 3. Oh, that's a word problem. Researchers wanted to determine if listening to classical music can reduce math anxiety. They divided 100 students randomly, that's a key word here, into 2 groups and put them in identical rooms. Both groups completed a math test and a survey rating their level of math anxiety. One group then listened to classical music for 10 minutes while the other group sat quietly. Both groups then took another math test, rated their level of math anxiety, and the researchers compared the results. Is this an observational study or an experimental one? Definitely it's experiment. Experimental because they designed the experiment. They were not like just watching something occurring and try to collect data from it. They didn't observe that. So definitely it's not, this is observation. So I take away 1 and 2. It's experiment because one group was randomly assigned, yes, to listen to classical music while the other was not. So it's like a placebo when you give some group of patients who don't know what they are taking an actual medication, and the other half you give them a placebo. It's just water. They're not taking anything, and compare the results because you don't want the patient to know that they took a medication or they didn't take anything. So it would be that's an experiment you design. It's an experiment because the participant took a math test. Yeah, if they were taking a geography test, that wouldn't be an experiment, right? Okay, so it's number 3. That's number 4 is a joke. Okay, the log problem. Which graph represents the function y equals log of 1/2, log to the base 1/2 of x? Notice that if the base is less than 1, then these two can be excluded right away because that's a base is greater than 1 for a log. These are less than 1. But they give you 1/2 and 0 versus 1. It's always 1 and 0. Why? Because if x is 1, log to any base of 1 is 0. Log 1 is 0, right? Whether the base is 1/2 or 5 or anything. So we know that this is the correct one. So it's number 2. Log of 1/2 to the base 1/2 would be 1. So that would have been 1/2 and 1. And you can see 1/2 and 1 would be here. And that would be also number 2. But anyway. The height of the water at Cape Cod, Massachusetts is shown on the graph below. If the height of the water h of t is measured in meters and the time is measured in hours since high tide, what is the equation for the height of the water? Well, if at 0 we start with a max, so that's a cosine. Yeah, all of them are cosine. We know that if the period was 2 pi, I will have this to be just t without any coefficient, right? But if it's anything else, I divide 2 pi or I divide 2 pi by that. So here the period is 12, right? Here is the max from 0 to 12. So 12 divided by 2 pi. If that length was 2 pi, I would get 1, and that would be just t, cosine t. But 12 over 2 pi is 6 over pi t. I'm sorry. I'm sorry. This is 2 pi over 6. 6 over pi would be the number of periods, or I did it backwards. I'm sorry. Yeah, you divide 2 pi, because if you get cosine of x, you know that the period is 2 pi. And then If it's less than 2 pi or greater than 2 pi, it doesn't matter. If it's different from 2 pi, you divide 2 pi by that. So you get pi over 12 is pi over 6. So it's this or that, right? So we excluded pi over 12. Okay, what do we do after that? First of all, the center line, which would be this part, how high it is, you see that the minimum is 0.4 and the maximum is 3.4. And the center line is exactly in the middle. What's the meaning of in the middle? This plus that over 2. 3.8 over 2 is 1.9, so the answer is 2. So what about this 1.5? 1.5 is the amplitude, meaning if this is the center line, the amplitude is the difference between max and center line or center line and min. So 1.9 minus 0.4 is 1.5, or 3.4 minus 1.9 is also 1.5. And again, I'm sorry, I was doing the period versus the the frequency. Okay, so the solution of 3x squared minus 4x plus 2 is, so you use the quadratic equation, you get, this is a, this is b, b is negative 4 and c is 2, so you get negative b, which is 4, plus or minus the square root of b squared, which is 16, minus 4 times 3 is 12, times 2 is 24, over twice a, which is 6. So you get 4 plus or minus root of negative 8 over 6. 8 is 4 times 2, so when you take the 4 out, it comes out as 2. So it's 2, since they wrote it at the real part first and the imaginary, 2 over 6 is 1/3, so this would be root 2i over 3, which is 1. Okay. Next, number 7, it says the value of sine of 2 pi over 3. Notice sine of 2 pi over 3 is the same as sine of pi over 3. Because we are in the second quadrant, 2 pi over 3 is 120, pi over 3 is 60, and you get the same, which is sine 60, which is square root of 3 over 3. Okay, how about this guy? This is square root of 3 over 3, so it's not correct. Cosine 30 or pi over 6, yes, it is correct. So it's number 2. And notice that the cosecant is 1 over sine. So unless the sine is 1 or negative 1 at pi over 2 or at 3 pi over 2, the cosecant cannot equal the sine. It's always going to be greater than the sine, except, as I said, when the value of the sine is, if that was pi over 2, then yes, cosecant pi over 2 also would be the same. Number 8, given this is the inverse function, what is the function that represents the inverse of the inverse? So in other words, you use this as x, and this is f of x, and you solve for f of x. In order to reach the f of x, the f of x is multiplied by 4 and then added 1, and then it raised to a power of 1/3 or cube root. So I have to raise both sides to the 3rd power so that the root with the cube cancel, and you get 4 f of x plus 1 is x cubed. I subtract 1 from both sides. So I get x cubed minus 1 equals 4 f of x. And then I divide by 4 both sides. And I get f of x is x cubed minus 1 over 4. That's wrong. Number 2 is wrong. Number 3 is correct. 1 over 4 times x cubed plus or minus 1. This one is, only the x cubed is divided by 4, but the 1 is not, so it's wrong. 9. In order for a school to purchase graduation gowns, The heights of all the high school seniors are recorded. The heights are approximately normally distributed with a mean. So if we assume it's normally distributed, we say mu equals 64.7. In fact, it's x bar, but if it's approximately, we say that sigma or S is 4.267. They want the probability that X is between 65 and 68. Some people say, no, it's greater than or equal. It doesn't matter. For continuous distribution, the equality doesn't matter. Whether you say greater than or equal, or greater than, less than or equal, or less than, it doesn't matter. So we are going to use the the distributions. I have to go to the cumulative. You enter the lower value first, 65 comma, the maximum value, the mean, and the standard deviation. 0.2523. So it's 3. That's easy. Didn't do anything. Consider the system of equations below. The x and y value of the solution of the system are, one of them is rational and one imaginary. Both are rational, one irrational, or both irrational. In fact, you cannot have one rational and one imaginary. It's impossible because imaginary, like rational, come in pairs. So I can exclude that. Also, irrational come in pairs. So 1 and 3, just by looking, you can exclude them. So it's either both rational or both irrational. Anyway, x is 2. So if we substitute, you get 3 square, because 2 plus 1 is 3, 9 plus y minus 4 square equals 9. Well, you subtract 9 from both sides, and you get y minus 4 square equals 0, so y equals 4 or y equals 4. Both are rational. The only value is y equals 4. 2 and 4 is the only solution. Okay, which expressions are equivalent to that? Oh my God. Okay, so the first one is 36x squared minus 9. When you multiply it by x squared, you get 36x to the 4 minus 9x squared. So this is correct. But you may have more because they tell you, is it 1 and 2, 1 and 3, 1, 2, 3, or 1, 3, 4? How about the second one? If you multiply the ones inside, you get x squared minus a quarter. So when you multiply that by 36, there is no x to the 4 term. Well, I'm sorry, this is x to the 4. There is no x squared term, right? There is no x squared term. You get 36x to the 4 minus 9. So this is wrong. So I know that 1 and 3 are wrong. So really if you are smart, I'm not going to check 3. I check only 4. If 4 is there, I use 4. If 4 is not there, I would use 3. Right? Do you see that? So 4. 36x squared, and this is x minus a quarter. X squared minus a quarter, I'm sorry. 36x to the 4 is that, minus 9x squared, so that works. So 1, 3, and 4. 3 is definitely there because I excluded this one because there is no 2. I excluded that one, and both of these have 1 and 3. So if 4 is there, it must be 4. A deposit of $1,250 is made into a savings account that earns 1.86% annual interest. The amount in this account at any time is modeled by A of t is 1250 times 1. Yeah, of course. Which expression best models the equivalent monthly growth of the account? They definitely wanted you to divide the 0.86% by 12, which is not correct, because if you do that, it means the money is compounded monthly, not annually. I don't know if you learned that. You will learn that if you take a course in like economics or I taught a course in engineering economics for years and years, and this was a common problem there. Now, you wanted a value that when you raise to the 12th power, you get 1.0186. So if I say, or if I say 0.86%. Okay, so how would you do that? 0.0186. No, I don't want to do that. Okay, I'm sorry. 1.86%. I'm sorry, so it's 1.0186, right? And you want to raise that to the power of 1 over, let's delete this. And you get 1.001536. So 1.001537, that's 4. Don't divide it by 12. Okay, if you divide it by 12 and then raise that 1 plus that to the power of 12, you will get a value much higher than 186. So it's 4. Okay, you take the value and you raise it to the power of 1 over 12 to get it per month. Because now when you raise it to the power of 12 again, you will get back 1.0186. Next page, number 13. Which graph represents a function that has a remainder of 0 when divided by x minus 4? It's another way of saying which graph of these passes has a 0 of 4, right? If it has a 0 of 4, meaning it's divisible by x minus 4. 1, 2, 3, 4. 1, 2, 1, 2, 1. So it has to be number 1. That's the only one that will be divisible by x minus 4. Given a being greater than 0, which expression is equivalent to that? That's a simple problem of exponents. When you multiply this can be written, let me write it first as a fraction. Cube root is 1/3, a to the 2/5. It's a 5th root of a square divided by a to the 1/2. So it's a to the 1/3 plus 2/5 minus 1/2. Common denominator of 30. 3 becomes 10. 5 becomes 6 times 2 is 12. 1/2 becomes 15. 22 minus 15 is 7. So a raised to the power of 7 over 30, which is 2. Again, very simple calculation of like subtraction. Which function could represent the sketch below where a, b, c, and d are all greater than 0? Okay, so each one of them has to have a term x plus a, right? X plus a, so I exclude the next two. Both have to have minus d, so it must be 1. And you say, oh, but what is that? Yeah, this is cx plus b. So if you factor c out, it will become x plus b over c. And you have a negative b over c, so yes, x plus b over c. But you don't need to do that since this is d over 2, this is d. Number 16, before leaving for summer vacation, 447 students at high school were asked whether or not they had a job for the summer. The results of the survey, broken down by students' averages, are shown in the table below. Why do I care if they were 400? Well, we'll see. The probability that a student has a job, given that, that's a conditional probability. So when I say given that, my sample is not the 447 students anymore. It's those who satisfy the condition. The students' average is between 90 and 100. 90 and 100 is that. So my population size now is 87. And 52, which one have or don't have? Oh, this one has a job. Yeah, to the nearest 100 is 52 divided by 87. It's as simple as that. 52 over 87. And to the hundredth, that would be 0.60. So it's number 4, 60%. Do you see that? Okay. Wow, that's 16. Okay, I don't want to make it long. Okay, the expression 3x cubed minus 4x squared minus 17x plus 6 over 3x minus 1, where x doesn't equal 1/3, is equivalent to. Okay, so that's a long division. So you can write 3x cubed minus 4x squared minus 17x plus 6 over 3x minus 1. So you get x squared, that will give you 3x cubed minus x squared, and then you subtract those. So you get negative 3x squared minus 17x plus 6 divided by 3x, you get negative 3. So that's negative 3x squared plus, I'm sorry, x, negative 3x squared. Wait a second, what did I do? I divided this, so it's negative x, not 3. Why did I get the 3? So x times 3x is negative x times 3x, negative x squared, and this is plus x. So when you subtract, that would be negative 18x plus 6. Negative 18x over 3x is negative 6. So you get negative 18x plus 6. Subtract, you get 0. And this is the answer, x squared minus x minus 6. But we don't have that. It's not 4, so you have to factor this out. It's x minus 3 times x plus 2. Right? Which is 2. By the way, I said in a different video, I don't know if you have watched it or not, is that when I was a kid and I didn't have a calculator, it was easier for me to assume x is 10. And you said, oh, but x, they tell you it's not 1/3. Yeah, I just used 10 because 10 was easy. See how I can solve this problem and check my answer very quickly. 3x cubed, x cubed is 1,000, so it's 3,000. X squared is 100, so minus 400. X is 10, so minus 170, plus 6, plus 6. I divide that by 30 minus 1 or by 20. Divide that by, okay, I'm sorry. Divide that by 29. I get 84. Now I look at my answer. I got x minus 3, which is 7. X plus 2 is 12. And 7 times 12 is 84, so I check my answer. If I had picked this one, I would have gotten 13 times 8, which is 104. And I say, oops, I did something wrong. It's a quick check, but you know, if you know what you're doing, you don't need it. I just said. 3 students put their first step to solve the equation x squared minus 4x equals 9 on the board at school. And all of them were trying to complete the square, right? So you know that you will divide negative 4 by 2, you get negative 2, square it, you get positive 4. And then you say this is x minus 2 squared, this is root 13, and then you take the square root plus or minus 13 and you add the 2. So this guy said, okay, of course, this is not the square root of square root of x squared is x, and square root of 4x somehow is 2x, so that's wrong, definitely wrong. Yeah, this guy added 4 and 4, so that's correct. This guy said, yeah, I've seen student very minimal number, but they say, oh, if x times x minus 4 equals 9, so either this equals 9 or that equals 9. This only works for 0. Because if you multiply two numbers and one of them is 0, the answer is 0. But if you multiply two numbers, one of them is 9, the answer may most likely will not be 9 unless the other one is 1. You see what I'm saying? So that's definitely wrong. It's only Gus. So it's number 2. Okay, 19. The average depreciation rate of a laptop is approximately 33.3% each year. If Garrett purchased a new laptop for 700, which recursive formula represents the value of his laptop n years after it's purchased? Excuse me. If the value depreciates 33.3, then every year it becomes 66.7% of the previous year, or 0.667. Not 67. Okay. A0 is 700. Yes. A sub n equals the previous year times point. Yeah, that's definitely correct. How about 2? A0 is 700. Yes. But this becomes 1/3, meaning the depreciation rate would be 66.7. It's definitely wrong. This one would be correct if I don't have a -1, if it was 7,000 times 0.667 to the n. So that's wrong, and that's definitely wrong. It has, so it's 1. We knew it's not a multiple answers. Given that the directrix of a parabola is at y equals 7, the focus is 6 units vertically away, but they didn't tell you above or below, because the parabola may be opening up, and this would be here, or down, and the focus would be here. So the y of this would be 13, and the y of this would be 1. We know that the vertex is midway between the directrix and the focus. 1 and 7 is 8, divided by 2 is 4. 7 plus 13 is 20, divided by 2 is 10. We don't have anything with 4, 3. We didn't know what the x were, so it can be anything, but 10 is the correct answer. So it was opening up. The directrix was at 7, the focus 6 units above at 13, so the vertex is only half of 6, or 3 units above the 7 or 10. How many values of x satisfy the equation 1, 2, 3, 0? So it's not 4. Oh, here you have to be very careful with absolute value. Let's move the absolute value to the left. So the equation is absolute value of 2x minus 3 equals 5 minus x over x minus 1. Okay. So I either have 2x minus 3 equals 5 minus x over x minus 1, or I have 2x minus 3 equals the negative of that. So it equals x over x minus 1 minus 5. In this case, when you multiply, you get 2x squared minus 3x minus 2 minus 5x plus 3 equals 5x minus x, 4x minus 5, right? 5 times x minus 1 is 5x minus 5, and then you subtract x, you get 4x minus 5. When you move them, so when you add 4x, subtract 4x and add 5, that would be 2x squared minus 9x plus 8. If you do the same thing here, we said this is 2x squared minus 5x plus 3 again, equals, and this would be x minus 5x, would be negative 4x, of course, plus 5. So when you move them to the, when you add 4x, this would be negative x, and when you subtract 5, you get negative 2. And then you use the quadratic equation. That's why I said you should expect to get 4 answers, right? Plus or minus, plus or minus. Here there is a trick, and you have to think about the absolute value. Can the absolute value be negative? No. So definitely one of these 4 answers, if you use its x, the right-hand side would be negative. So you'd say, oh, the absolute value of 2x minus 3 equals, for example, negative 3. It's impossible because the absolute value is positive. It's a V-shaped equation above the x-axis, or it may be below, but what I'm saying is it cannot be negative, the absolute value itself. Alrighty, so what do? We solve. So if you solve that, you get x equals negative b, which is 9, plus or minus square root of 81 minus 4 times 2, 8 times 8 is 64 over twice a, which is 4. So you get 9 plus or minus square root of 17 over 4. Okay, what about this? X is negative b, which is 1, plus or minus the square root of 1 minus negative times negative is positive. 4 times 2 is 16 over 4. So 1 plus or minus also root 17 over 4. So these are 4 solutions. One of them definitely may be a problem. If this is x, 9 plus that over 4, and x over x minus 1, that would be, so roughly this is 4, right? 4 point something, but let's say it's 4. So you get 13 over 4, which is 3.25 divided by 2.25. That's less than 5, so it's not a big deal. When you do the plus, this the minus, 9 minus 4 is 5 over 4 is 1.25. Wait a second, let's see that. 9 plus square root of 17 divided by 4. It's 3.28. So x minus 1, no, that would be fine. So what about 9 minus, well, you know what, between parentheses, 9 minus the square root of 17 over 4. It's 1.22. So if x is 1.22, then x over x minus 1 would be 5.56. So here you would say 5 minus 5.6 is negative. The right-hand side would be negative, and this equation is impossible. So I exclude 9 minus, so this would be only 9 plus root 17 over 4. You see why? It's 9 minus root 17 over 4 is 1.21. If you divide it by 0.219, you get a value greater than 5. So subtracting x over x minus 1 will be a negative quantity. When you are here, this has to be greater than 5 for this to be positive. I'm sorry, this also, yeah, this has to be greater than 5. So let's say 1, again, between parentheses, 1 plus square root of 17 over 4 is 1.28. If I divide that by 0.28, I get, wait a second. This was greater than 5, so we excluded it. So how come this one also? This one also. Oh, no, the absolute value. I'm sorry, it's here. So, so when I say no, that is fine, because here I would say 1 plus square root of 17 divided by 4, and then I say divide by this minus 1, and it's 4 point, so 5 minus 4.56 is positive, and if it's 1 minus the square root of 17 over 4, and I divide that by this minus 1, I get 0.43. So again, 5 minus that is positive. So these two roots are fine. This root is fine, but 9 minus root 17 is wrong. So that problem was tough. That was tricky. But since they didn't say 1, 2, 3, 4, and we would have, most of us fell for it and picked 4 because you have 2 solutions for every quadratic equation. Because they didn't have the 4, we had to think why 1 is missing. And the only possible way it's missing is if the left-hand side, since it's an absolute value, the right-hand side cannot be negative. So if one of these answers has x over x minus 1 greater than 5, then you say, okay, it doesn't work. And when we tried 9 minus root 17 is likely roughly 4. So 9 minus 4 is 5. 5 over 4 is 1 and a quarter. And when you divide that by 1 and a quarter minus a quarter, you get 5. But this is not, you are subtracting more than 4. So really, this is smaller than that, and this is smaller. And when you divide, you get more than 5. You get 5.56 or whatever we got. So that quantity would be negative. So we exclude that, and the answer is 3. This is really a good one. Number 22. The tangent of an angle in standard position that terminates in quadrant 2. So the angle is like that in quadrant 2. And it has terminates, the tangent. So the tangent of this angle, let's call it theta, is negative root 6. Okay, so of course the negative is the horizontal because the vertical is positive in the second quadrant. Okay, negative root 6. I'm sorry, negative 1, and this is root 6 to get a tangent of negative root 6. So using the Pythagorean theorem, negative 1 squared is 1, root 6 squared is 6, 1 plus 6 is 7. So this is root 7. It's not a unit circle, it's a circle, but with that, what is the cosine? The cosine is adjacent over hypotenuse, negative 1 over root 7, which is 4. Okay, nice. Only 2 remaining. Miranda joins a gym and pays an annual membership of $400. Due to rising costs, the gym operator had told her the membership will increase 8% each year after the first year. How much will Miranda has paid in total to the nearest dollar if she is a member for 6 years? So really, it's 400 plus 400. So if you factor out the 400, you get 1 for the current year plus 1.08 for the second year. So that's the first year plus 1.08 square for the third year. And for the 6th year, it would be 1.08 to the 5th. That's a geometric series. And we know the sum of the geometric series is a to the n plus 1. So it should, 400 is there anyways. And then you multiply by 1.08 to the 6 minus 1 over 0.08, over 1.08 minus 1 if you want. So 400 times 1.08 to the 6th power minus 1 divided by 0.08, 2934, it's 3 to the nearest dollar, 2934. So you should be able to remember the sum of the geometric series. Finally, the last problem, it says Miss Miles observed slides of bacteria under a microscope. She found that over a specific amount of time in hours, the population was growing. She graphed the results of the population in thousands of the bacteria over time and got this. Assuming exponential growth, which statement is true? The population can be modeled by P of t equals 2 times 4 to the t. Well, at time 0, that would be 2, so that's correct. At time 1, which is here, I should get 2 times 4, which is 8. This is, we said this is 4, 5, 6, 7, 8, okay. We don't know time 2, but we have time 1.5, it doubles. It's exponent. Should I multiply 8 root 2? Because it's 0.5, 0.5, so root 2. 1131. Oh, yeah, it is. And that should be the same, right? So, okay. So this seems to be correct, the first one. Let's look for the second one. The model is, if t is 0, you get 378. This is 4, not 378, but let's see what happens at t equals 0.25. 3.92 times 0.25 plus 378. 476, yes, it is. Okay. Oh my God, 3.92 times 0.75 plus 378, 672. Okay. How about 1.5? 392 times 1.5 plus 378. Oh, that's way off. Oh, so that was, the population approximately doubled every hour. So at 1 hour, it was 1. At 0 hour, at 1 hour, 1 hour, it became 8. So the 4 became 8. That's what, wait a second, didn't we do that? I'm losing my mind. Yeah. And then we said it, so we said this is wrong. How did I get this before that? What did I do? So this is wrong, this is wrong. This is correct. The population was 4 at time 0. At time 1, it became 8. I did this without seeing that probably. I don't know. Yeah, it's 3. You see that at time 0, it was 4. At time 1, it became 8. We didn't have time 2, which should be 16. But midway, because the power is 2, you get 8 square root of 2. And 8 square root of 2 turns out to be 1131 exactly. So the answer is 3. And that concludes the part 1. It took long, but I wanted to finish it and get done with it. And then we'll see what we are going to do with parts 2, 3, and 4. If you have any questions, please let me know by dropping me a line in the comment section. Otherwise, I wish you all the best and hope to see you soon. Bye.